Assalamualaikum and a very good day. My name is Mohamad Azam Ramli. My ID is 2019326415. I am engineering student from UITM Shah Alam Selangor. Today I will present my final year project presentation to fulfill my syllabus course get my degree. My supervisor for this topic is Dr. Mohamad Faizal bin Mohamad and my co-supervisor is Dr. Mohamad Shahriman Adenan. Computational Fluid Dynamics (CFD) simulation on horizontal tube furnace. Project summary: this research involves simulating the mixing of three different gases of methane, ammonia, and nitrogen using computational fluid dynamics (CFD). The gases mixing will be mixed in three different intake positions inside the horizontal tube furnace. The gases mixing will be placed at a constant temperature of 500 degrees Celsius in a low temperature nitrocarburizing hybrid process, and all of this will be accomplished using open software. Table of contents. The project overview. Introduction, literature review, methodology, result and discussion, and conclusion are all included in this presentation. This 5-point table of content will elaborate on horizontal tube furnace simulation detail. Number 1. Introduction. Background. The horizontal tube furnace is referred to a heating device, but its precise definition, device used undertake process synthesis and purification of inorganic chemical products. Using electrical energy source, the horizontal tube furnace may reach temperature about 1000 degrees Celsius. This furnace is advantageous because it has single zone chamber, which allow the heat circulate 360 degrees across the face. The furnace has been used in a variety of thermal processes, including annealing, drying, coating, calcination, and accelerated aging. An investigation using horizontal tube furnace in low temperature nitrocarburizing hybrid method revealed that the technique is effective to enhance the surface quality of duplex stainless steel without changing the anti-corrosion capability according to the previous study. The creation of hard diffusion layer known as expanded austenite and expanded ferrite demonstrate the improvement. Not to forget, another investigation involved multi-specimen revealed that the surface improvement is not uniform in layering. Finally, the purpose of this research was to investigate the impact of the flow mixing of three inlet positions within a horizontal tube furnace. Problem statement. There are a few issues that were present in previous projects. Firstly, what variables should be considered and how might they influence the heating process inside horizontal tube furnace? The result is seen by response of fluid flow and the enhance of the surface input. After that, the hybrid process creates a non-uniform layer thickness on the specimen. This might be related to a lack of fluid flow interaction with the specimen. Furthermore, what are the effects of flow mixing on velocity inside horizontal furnace? Objective. The goal of this study is to look at the flow structure that appear when mixing fluid flow occur inside the horizontal tube furnace. By that, three inlet positions of horizontal tube furnace with different velocity value being studied. Next, to evaluate the velocity profile and velocity contour when different positions of velocity inlets been applied. This can be observed through graph and illustration given at the result. Number 2. Literature review. Research. CFD is defined as mathematical application of conservation law with boundary and initial condition. It used for calculating variable quantity based on the product. The CFD, for example, can calculate heat, motion, force, and other variables. This software was initially introduced in the early 21st century, and demand of it has grown dramatically as a result of globalization and technological development, like as the internet. To perform this simulation, the program required 3D numerical model data. Meanwhile, fluid flow is classified as either external or internal, and for this project, the fluid flow was classified as internal because it occurred in confined space. Laminar, turbulent, and transitional flow are three forms of flow that might occur in another situation. As example, a transitional fluid flow happens between laminar and turbulent with the Reynolds number 2300 to 4000. Moreover, friction factor also affect the fluid flow as turbulent flow happens inside confined space. And not to forget surface roughness. Finally, since the Navier-Stokes NS equation cannot answer the turbulent condition in fluid flow, the Reynolds average Navier-Stokes RANS equation are generated from the NS equation. The usage of K epsilon in this project can be notified since the accurate performance of CFD can be obtained using normalization RNG. Number 3. Methodology. Here are a few steps that must be followed in order to finish this project. To begin, the specimen, alumina board, and horizontal tube furnace are all measured using unit millimeter. Using SolidWorks software, the dimensions were used to build a 3D CAD model for all parts. The complete 3D CAD model assembly then be transferred to an STL file for inspection. If there is any issue with the assembly, a new drawing update is required to ensure that the assembly is precise. If there are no issues, the STL file may be used to set up boundary condition, machine, and solution setting with OpenFOAM software. In the boundary condition, all value of velocity, k, epsilon, and more been calculated with different value of velocity. After that, the CFD simulation for all cases was run. After the simulation is completed, the data is analyzed. Next, for the data analysis, come up with result and discussion. Lastly, repeat step from boundary condition, machine, and solution setting different value of velocity. Number 4. Result and discussion. Here are 4 average residual that been observed to make sure the graph converges. It is to make sure all measured variables like pressure, velocity are fully analyzed graphically. For case 1 and case 2, the graph has completed the converge at low 20,000 iterations. It makes the velocity and pressure cannot study after 2,500 and 19,500 iterations for case 1 and 2. Meanwhile, the case 3 and 4 still can produce results higher 20,000 iterations because the graph still not stopped. This would affect the measured variable result. The velocity contour showed higher difference at inlet position as different value of velocity inlet. It could be arranged upward from case 1, case 2, case 3, and case 4 from the visualization. Although the value given at U magnitude shown the higher value at case 2 with 1.769 exponent -1 and the low is case 1 with 1.348 exponent -1. Meanwhile, the visualization at middle tube show slightly different velocity contour due to same sizing and amount of specimen. Moreover, the outlet value shown same velocity contour as the furnace length and outlet size is same for all cases. The difference of velocity contour happen due to different inlet position, especially at inlet position. The velocity profile was taken at point 0 in the middle of horizontal tube furnace. For all cases, case 2, case 3, and case 4 show same result with higher velocity of 0.13 meter per second and 0.044 meter for y direction. It happened because the value of one inlet position been increased to 2.5 meter per second. Meanwhile, the higher velocity value for case 1 is 0.13 meter per second and 0.043 meter for y direction. By that, related that the higher velocity inlet, the higher velocity profile for confined space. Number 5. Conclusion. Cases 1, 2, 3, and 4 of this horizontal tube furnace simulation has been completed. The average residual velocity contour and velocity profile were calculated using CFD simulation. Different inlet position result in different flow structure. Although the velocity profile was recorded in center of the horizontal tube furnace, the thickness of the surface characteristic could not be studied in this project. It happened to reduce simulation duration. Because the velocity profile is low and visible via a velocity contour, case 1 has become the most uniform velocity. Meanwhile, relative to the equal amount of velocity increase, case 2, case 3, and case 4 has slightly different value in velocity profile. Therefore, with value of 1.769 exponent -1 meter per second, case 2 has the greater velocity profile. In addition, there are a few factors that might be improved in the future. To begin, increase laptop capacity so that a student can access one laptop for their final year project. Second, raise the velocity difference from 2.5 meter per second to 5 meter per second or greater, since this will get a better result. Last but not least, simply iteration would utilize to shorten simulation duration. Thank you for watching my final year project presentation. Hope the panel and audience enjoy this presentation, and if any question may ask me through my email and WhatsApp even.